So there's still more for us to talk about regarding basic Linux skills. Again, Linux ships with hundreds of useful commands, of which you're required to know a good fraction of them because they're very useful and will help you to administer the system. At this stage, let's turn our attention, instead of enumerating through additional commands, to some basics of Linux, including redirection and piping. So we'll label this section, and then we'll continue with the command list. Linux, redirection, and pipes. And the features include ability to send input or to control input and output, or I/O. For example, using input redirection, we can influence the flow of information into a program. Usually, however, input redirection isn't explicitly indicated. It's usually implicitly indicated. As an example, if we wanted to cat the contents of one of our text files, such as 123.txt, this uses input redirection. The input redirection takes place when the contents of 123.txt are sent to the cat program, which then sends it to standard out. So cat reads 123.txt using input redirection, but we can explicitly denote input redirection using a less than symbol. So input redirection makes use of the less than symbol. Let's navigate to the shell to take a look. Again, here are our files. If we cat 123.txt, this uses input redirection. And if we explicitly indicate input redirection, the same occurs. In both cases, the exit status returns cleanly, and that wasn't the exit status. It returns cleanly. So this is input redirection. Sometimes with programs, let's say sendmail, if you want to send a message from the shell, you will explicitly specify input redirection because the program doesn't default to input redirection from the command line from a file. So note, use input redirection when program does not default to file as input. Usually this is where the input is going to come from when you indicate input redirection. So for example, as mentioned, send mail, input redirection, the name of the text file to be mailed. More interestingly are the other two forms of redirection: output redirection and append redirection. Output redirection makes use of the greater than symbol. For example, cat the contents of 123.txt, output redirection to, let's say, 123.txt. This takes 123.txt as input, so it's redirected to the cat program, which then sends the contents of 123.txt using output redirection to a file named 123.txt. Remember, the nature of most Linux commands is to send the output or its output to the screen. However, we can influence or change or redirect using a greater than symbol. So let's try this out to see what happens. Clear screen, Control-Shift-V to paste, and it doesn't appear as if much has transpired. However, if we echo the exit status, all has transpired well, and an LSLTR reveals a newly created file 123.txt, which is of the same size as the numeric version of the file. So when we cat the contents of 123.txt, it contains the numbers 1, 2, 3. So that's using output redirection. Now output redirection also clobbers files, so you have to be very careful. For example, if we execute cat 456.txt to 123.txt, it will clobber first 123.txt and then populate it with the contents of 456.txt. Let's show you what we mean. So cat 456.txt using output redirection to 123.txt. If you're unfamiliar with the way output redirection works, you may believe, or may be led to believe, that this will append the contents of 456.txt to the contents of the string version of 123.txt, but it will not. Whenever you use output redirection, that's a single greater than symbol, the command will clobber the file first, or shell redirection will clobber the destination file first, and then perform population. Let's show you what we mean. The exit status will be clean because the input file was read and the output file was created. There were no disk space issues, so all has run well. However, when we now cat the contents of 123.txt, it contains 456. So, output redirection with greater than symbol, be careful. Let's just note, default nature is to clobber, or is to clobber the target file, which means it zeroes out the target file, then populate with information from input stream. So if your intent is to not clobber the output file, then make use of append redirection. That's the other form of redirection. Append redirection makes use of one more greater than symbol. So there are two greater than symbols juxtaposed, which means a cat of 123.txt with append redirection to numbers.txt will clobber the file if it doesn't exist, or in other words, it'll create the file if it doesn't exist. So append redirection creates numbers.txt if it doesn't exist, or appends if it does. That's the difference with append redirection. So let's give this a try. Cat 123.txt to a file that currently doesn't exist. And then lsltr will reveal that we now have numbers.txt, and it contains the numbers 1, 2, and 3. Then let's follow that up with a similar command, but this time we'll cat 456, and instead of clobbering, it will simply append. But there are times when you will need output redirection, which overwrites or clobbers the file, as opposed to append redirection. Now this file will be 12 bytes, numbers.txt, as you can see, 12 bytes, and it includes 1, 2, 3, 4, 5, 6. So that's append redirection as opposed to output redirection, and there's also input redirection, which is more subtle, and it's usually implied. So those are the three basic forms of redirection: input, output, as well as append redirection. So how about pipes? What do pipes do? Well, first you indicate that you want to pipe by using the pipe character, which is located beneath the backspace key on your keyboard. Pipes connect output stream of one command to the input stream of another command. So it connects the output stream of one command to the input stream of a subsequent command. For example, we may cat the contents of 123.txt. This will typically dump the output to standard out. But if we want 123.txt to be processed by another command, such as sort, this is a perfect opportunity to use piping. Pipe it to sort, and then sort will take on its input stream the information sent to it from cat's output stream, and then perform its function. So this is a way to combine two useful commands, cat and sort. We can also cat first, let's say 456.txt, then 123.txt, then send the output to sort. But let's see what happens in this case. Nothing much will happen since the data is already sorted. We'll clear screen, cat it, and again, nothing fancy because it's already sorted. However, what if we were to change this around a little bit? As we've just mentioned, by indicating 456.text first, and then 123.text. Well, under normal circumstances, this would first cat 456.text, then 123.text, which means the data are unsorted. So, to clear things up, let's pipe the output to sort. And now the data is sorted. Now, of course, cat would normally sort the data if the data, or present the data in the format that it is in. If it's sorted, it will be presented in a sorted fashion, but it does not auto-sort. Sort does. So here's a way to pipe one command to another command. And you can combine piping to perform some very nifty tasks on a standard Linux box. So we can cat, then sort, then grep, for example. Let's grep for line 3, or a line containing the number 3. And now we've piped twice. We've sent the output of cat, which read 2 files on its standard input, to the input of sort, which sorted the data and sent it to the input stream of grep, which filtered the output to the line containing 3. So these are some of the ways you can use pipes to construct powerful commands. And all throughout Linux and Unix, piping, output redirection, append redirection, input redirection are used very heavily to get a lot done. Now let's move on to some other features of the shell. Another neat feature is the ability to chain commands. Command chaining provided by the bash shell permits the execution of one or more commands. So we'll just say multiple commands in sequence. And it also includes logic to allow us to execute commands based on the success or failure of a previously executed command. So also permits execution based on the success or failure of a previous command. The basic usage of command chaining resembles the following. Let's say we want to first cat the contents of 123.text, then LSL to execute a directory listing of the directory that we happen to be in. You can't simply specify cat space 123.text space ls-l, as ls space -l will be read as options to be passed into the cat command. However, if you separate these items using a semicolon, the bash shell knows that you want to run this command immediately followed by this command, without regard for the success or failure of the previously executed command. So, this runs first command, then second command, without regards for exit status of the first command. So there are times where you want to run a series of commands regardless of, or when there are no dependencies. And there are times when you need to run commands with dependencies. If there are no dependencies in the commands, if these are mutually exclusive, if these are independent commands, then use semicolons as your delimiter. So cat 123 space, or 123.text space semicolon space ls-l will execute both commands, pass or fail, for either command. Let's try this out. So there you see a cat of 123.text immediately followed by an ls-l. Both have run, and both have run successfully, indicated by the exit status. However, let's take this a step further. Now let's suppose we want to run ls-l only if cat 123.text has executed successfully. So cat 123.text, and if it has executed successfully, we'll run ls-l. In that case, you'll make use of the ampersand delimiter. This is a way to tell the shell, the bash shell that is, that only if cat space 123.text is executed successfully, meaning it has returned an exit status of 0, should we run ls-l. And we'll prove it momentarily by executing a cat with a command or with a file that doesn't exist. So let's reset the buffer. And now you see that both have run, so it doesn't appear to be any different from the recent run. However, take a look at this example. We're going to cat 1234.txt, which doesn't exist, and then see what happens. Let's reset the buffer once more. Now notice, because cat was unable to find 1234.txt, an error is returned, resulting in a non-zero exit status from the cat command. And because we use double ampersands, which is the logical ANDing which requires or relies upon a zero exit status from the first command, the second command wasn't run. So there is no ls-l, and if we echo the exit status, it's actually non-zero, meaning there was a failure with the first command. And you can command chain as long as you'd like, or as long as it's supported by the bash shell, by using ampersands or semicolons, or what we're about to show you, which is the pipe delimiter, double pipe delimiter. So, for example, 4, and we'll just separate it with space. Now supposing we want to cat 123.txt, but only run ls-l if cat123.txt is not successful. Now we use logical ORing. Logical ORing in bash is realized by using double pipes. So this runs second command if first command fails, whereas what we saw above is slightly different. This runs second command if first command is successful. Whereas the first option runs either command because they're mutually exclusive. Let's give this a try. So again, our expectation is ls-l will execute only if cat123.txt returns a non-zero exit status. Let's try it. And there you see cat123.txt executed, which gave ls-l no opportunity to run. Now the exit status is 0. In order to get ls-l to run, however, because we're using logical ORing, we need to have the first condition fail. So let's try cat1234.txt, and there you'll see that although it failed, ls-l executed. So with command chaining, we have the ability to execute mutually exclusive commands, commands that are dependent using the logical ANDing, as well as commands that are independent, or commands that should run if the previously executed command failed. So there is a dependency, but it's a failure-based dependency. So that's a little bit about command chaining, and you can use this to run many, many commands from the shell to parse data, to process information, to back up your system, and virtually anything you can come up with. Now this leads us back to the command lists, or the basic commands that you should be familiar with. So the 24th command, let's just be sure that we don't have a number 24 on the list, and the last one appears to be 23. So the 24th command is the more command, and we'll just combine it with less. So more or less. These are paginators. So these display textual data one page full at a time. So they're paginators which display text one page at a time. So for example, more, and we'll pick something that's long enough, that's worth our time. Let's go ahead and look at etcfs tab. So more etcfs tab displays fs tab one page full at a time. And programs like more and less know the dimensions of the shell that you're in, even if you're in a GUI, because as you adjust your GUI, notice towards the center of the screen, the dimensions are being recorded and reported. The dimensions are stored within variables within the shell, such that when programs like more and less execute, they know the dimensions of the screen and can display information accordingly. So let's try that out. Well, more etcfs tab. Now, if a file does not exceed the dimensions of your text window or of your shell, then there's no reason to display information one page full at a time. However, if the file does, then it will. And we'll give you a quick example. We're going to use another useful command, sequence, to create a file which contains the numbers 1 through 1000. We'll call it 1000.text. Now this file, certainly if we cat the contents of it, exceeds the dimensions, at least the vertical dimensions of the screen. So with that said, let's more 1000.text using tab completion. And there you see the benefit of more, the ability to display just enough information to fit within the screen, as well as the percentage of information of the document displayed on the screen. So this gives us a sense that we'd need to advance the screen about 100 times to see all the data. Let's just list that 25th command, and that's sequence. Sequence echoes a sequence of numbers. So for example, sequence 1000, using output redirection into a file named 1000.text, creates a file with numbers 1 through 1000. Very useful for all sorts of situations. And more allows us to look at this data one page forward at a time, and if you expand the dimensions, the vertical dimensions in this case of your window, more information will be displayed accordingly. But there isn't much room for us to go. Now to advance, spacebar. To go back, press B. To go forward, press F or B to go back. So it's F or B. Or to go forward, press spacebar. So you've got two options for going forward, spacebar or F. And you can advance through the information. If you hold down on space or F, it'll just keep scrolling through to the end of the document. Similarly, the less command will enumerate the contents of a document. So let's less 1000.text, and less will also display it one page forward at a time. And you can also use space, B, and F. So F to go forward, or space to go forward, and B to go backwards to navigate through the file. Additionally, if you have a compressed file, let's SU in. SU is yet another command, by the way. SU allows us to switch users. We should list that because you do need to know it, especially if you want to pursue certification. So SU switches users, or changes the user context. SU, with no options, attempts to log in as root, which means you'll need to know root's password. So back to the shell. We'll authenticate as root, and then navigate to var log, where we have all sorts of log files. And in here, we're hoping to find a compressed item, or some sort of compressed file that we can interact with. Let's take a look to see what might be of use, although the system hasn't been up that long, which probably explains why we see nothing compressed. But later on, when we look at compression, we'll show you that less has the ability to parse or display compressed files. So it'll decompress the files and display it for you rather easily. So we've got more and less. Less has more functionality than more, but both are paginators. They'll display information one page forward at a time. Sequence allows you to create a file filled with numbers. And again, sequence -- help, like with most commands, tells you how you may use it. By default, you indicate the first number and the last number, but you can include increments. For example, sequence, first number 5, increment by 5, last number 20, steps in increments of 5s up to the last number. So you can determine how you'd like your numbers to be laid out using sequence. SU allows you to switch users. If you're logged in as root, you can SU in as any user on the system without being prompted for authentication. For example, if we SU as Linux CBT, we will not be prompted. We are now logged into the system as Linux CBT. If we exit the SU session, we are now back in the system as root. And if we exit this SU session, we're back to the original shell, which was on sudo terminal, in this case 2, as the user, Linux CBT. So that's a little bit on more less, piping, output as well as input, and append redirection. And again, there are still many other commands. Let's just go through a few more. For example, if you want to see only the beginning lines of a command, and by default head will display usually 10 to 15 lines, but you can influence that. Use the head command. Displays opening lines of text files. So for example, head var log messages, which is the general log file on your Linux system, will display the first set of lines depending on what the default is set to. Let's SU in. Usually for log files you need appropriate permissions to be able to open the file. So we'll SU in, navigate to var log, and it's already in the history. So here we see head has returned a certain number of lines. You can even count the lines by piping the output to WC, which is another command, using the L option, and as we mentioned, 10 lines. So head dumps 10 lines to the screen from the document. It dumps or displays opening 10 lines, or the first 10 lines of text files. Whereas conversely, tail displays the closing lines of text files. So for example, tail and the same file name, var log messages, displays the last roughly 10 to 15 lines. And it's important because a log file may have information going back a year. So head can quickly tell you. And since most log files in Linux are written in a linear fashion, that means older items are towards the top, newer items are towards the bottom. So that's why you need tools like head and tail to get to the top and the bottom, versus using tools like Notepad within Windows to open the full file. For example, this log file could easily be a couple gigs big, and it would take minutes or maybe even crash your Windows system to open the entire file. Whereas head can simply interrogate the first n number of lines, while tail will interrogate the last number of lines, or the last n number of lines. So it's tail messages. And then you see the most recent entries in the file, leading up to the date, or one day before today. So there haven't been any issues, the system hasn't been rebooted, nothing traumatic has occurred, which is why the most recent entry is from January 9th. So we've got head, we've got tail, as two commands that are very useful. We've also mentioned that there's WC, 29th command. This command counts words and optionally lines of text files. I like to use it as follows: WC-L followed by the file name, such as var log messages, or WC-L for a file that we know, 123.txt, which should contain 3 items. Let's see what we get when we do WC-L on var log messages. Tells us that there are 14 lines in the file. How about when we attempt to, in Linux CBT's home directory, in the test RH5 directory, count the lines in 123.txt? And it contains 3 lines. So it tells you quickly. However, what if we didn't use the -L option? As we mentioned, WC's default nature is to count words as well as lines. So it counts the number of words, the number of lines, and if you WC-help, you'll see the options. Lines, characters, words are all counted when you use the WC option, or WC command without options. When you use the -l option, it simply returns a line count. So it primarily counts words and lines, but can be used to count characters as well. And there's still yet other commands that need to be explored. For example, what if you wanted to know the type of file that you're dealing with? Whereas in a Windows setting, files are usually indicated by their suffix. So .text means it's a text file that should be parsed by perhaps Notepad or WordPad. .doc or docx files are to be parsed by Microsoft Word, and so on and so forth. Well, in Linux, it's a little bit different. Associations are maintained, but they're not as important as the actual content of the file, which is the same on Windows as well, because if you try to open, for example, open a file with the wrong program, an error will be thrown. The file command is a very helpful file to help determine the type of file you're working with. Determines file type for all types of files, binary, text, so on and so forth. Simple invocation is file followed by file name, such as var log messages. File relies upon a magic file which contains strings that are common to different file types, such as PDFs, Word docs, different types of binary files, compressed files, so on and so forth. So let's try this. This tells us that the messages file is a text file. How about files in our current directory? File123.txt. It's also a text file. Well, let's find a binary file. What about the Linux kernel itself? File boot VM Linux. It tells us that it is a 32-bit binary file. And if you interrogate any file, it'll tell you what type of file it is, so long as it's able to look it up using its magic file capability. Now, if you execute man file, and man is another program that you should be familiar with, it returns man pages for the commands that you're likely to use in your environment, in addition to the options that you normally get when you use the -- help option. It tells you that you can also specify a different magic file, otherwise file defaults to user share file magic. Now, just a quick note about user share file magic. Let's copy and paste this file. Let's actually do a file against it. A less of this file tells you that it's a magic text file, by the way. A less reveals that it's an ASCII text file. But if you peer in, you'll see that there are different escape sequences that identify different types of files. Now, rather than going through this boring output, let's grep case-insensitive search PDF from that file. Here's how file is able to detect a PDF. It looks for certain strings in a document, such as PDF with a trailing backslash, exclamation, so on and so forth. It's even able to tell the difference between a Macintosh PDF versus a profiling data file versus a portable document file. It searches for these strings in the document, and that's how it's able to tell. And it looks for %PDF- in the document. So the magic file maintains a list of sequences and strings that are found in various file formats. The file program queries the header of the file to help determine the type of file that it is. Because even though a file may be binary, it is going to have visible text, namely text that reveals the type of file the file is. Again, there are many other commands such as ps, free, df, vmstat, so on and so forth, top, kill, etc. We'll be looking at those commands throughout our studies. We'll use them for different purposes. For example, to see what's happening in the process table at any given point in time.